Hi guys, welcome back. So now let's jump into the first section, which is a basic introduction to cloud computing. So, for those of you who are extremely new to cloud computing, just wanted to touch upon some of the main concepts in cloud computing and some key features that have led to cloud's popularity. So, the first is on-demand compute, right? So traditionally, before the cloud computing took off, we all were all used to having and owning our own data centers in our main locations, right? So we had to buy computers and servers, and and then install it, wire it up, network it, and just basically maintain it. So this was the kind of model from the 70s and 80s and 90s. So basically, the problem with that is there's a huge lead time for any new project, which requires new servers. We had to order it. It would take a few weeks for it to come in, and then we are spending capital. We're basically buying it. The company owns it, and those assets depreciate over time, and pretty soon it becomes obsolete, and then it's time to buy new computers. So what cloud did is change the whole paradigm, wherein you don't have to buy servers or hardware. We can actually rent them from these big hyperscalers or cloud computing companies, and we can scale that much faster. We have more momentum. We can come to market that much quickly. The second point is how to build resilient applications, right? Again, if you go back to the old on-prem model, it was very hard to provide the proper amount of resilience, because most of the time the on-prem applications were in one data center in one location. So if there was a catastrophic failure in that data center, like a power outage or flooding or earthquake or anything like that, your entire company's applications are at risk, right? But when we move to cloud computing, all of these big cloud computing companies have multiple data centers in a region and multiple regions spread across the world. So it's extremely unlikely that all of these data centers or regions will be impacted at the same time, and therefore, if you spread your applications to kind of load balance, for instance, across multiple data centers, you're building uh, highly resilient applications. The next point is about elasticity. um, Previously it was very hard to scale up your infrastructure because of the lead time to buy new servers, and it was always hard to predict your demand in the future, right? But with the advent of cloud computing, it's a matter of seconds. You can provision new servers or containers or storage or databases, right? Matter of milliseconds and seconds in some, many cases. You can immediately just tell, based on traffic, your infrastructure is going to automatically scale, and that was unheard of before the cloud. Finally, better security posture. Now that might seem a little counterintuitive. You might ask, how is that if I move my infrastructure, my application to somebody else's data center, how is it more secure? So the way this happens is because even though you're moving your application infrastructure to a cloud provider, you still own that infrastructure. Your network is still owned by you. It is just an extension of your on-premise network. So that firewall boundary and all that will be moved to the cloud. It'll extend from your on-prem to the cloud. So really, because you are moving to the cloud, it doesn't mean that everything over there is managed by somebody else, and somebody else or the cloud provider has access to your data or has access to your application. All of that is tightly locked down, and only you or your company will have access to your application and network. How does cloud improve security posture? With things like robust data encryption standards, data at rest, data at transit, with granular access control, which was very hard to do in on-prem, right? You have cloud provides a lot of innovations like just-in-time access. So if you want to access an application, it can give you access for an hour, a day, or so. Or even if you want to escalate your permissions to a higher level, cloud enables you to do that for a shorter period of time. Then plus there's continuous monitoring of your infrastructure. There is audit logs. There are security event monitoring tools like Azure Sentinel that is constantly monitoring your network and your traffic to flag against any potential risks or hackers or any trojans or any of those viruses. Finally, if you go with the PaaS, a lot of your security updates are automated, and patching and all of that is managed by the cloud provider. And finally, the cloud provides a lot of specialized controls for regulatory environments like PCI, credit card data, for healthcare HIPAA compliant workloads, for NERC, for utilities, and so on and so forth. Now let's look at some of the main players in the cloud computing market. We all heard of AWS, Azure, and Google, and those are the three biggest providers in the market. And as you can see, Azure is a close second to AWS. But I feel that with the advent of GenAI and OpenAI and ChatGPT, Azure is fast catching up with AWS. And in my opinion, Azure is going to actually overtake AWS in the coming years, because Azure is a first mover in the world of GenAI because of their investment in ChatGPT. AWS is catching up, but I feel that Azure will overtake AWS in the future. And as you can see, how much the revenue is growing from 380 billion in 2021 to 1.6 trillion in 2030. So definitely cloud is the future. Cloud is where everything is going to go in the foreseeable future. Now let's look at the shared responsibility model. What does that mean? It means that even if we move to the cloud, it is not completely owned by the cloud provider. There are still certain things that you or your company is responsible for. So this diagram compares 4 different models. So SaaS is mostly for applications that are entirely hosted. It's not really applicable for Azure. For Azure, really, it's the two middle things, the PaaS and IaaS, which is PaaS is where the entire platform is managed by Azure. For instance, there is this app service environment where you can actually just deploy your Java, .NET, Python apps, and all the infrastructure and network and everything is managed by Azure, meaning the servers behind the scenes are patched and maintained by Azure, and you are only responsible for things like identity, meaning who controls access to your application. You control the deployment applications, but the application is hosted in servers that are responsibility of Azure. Network controls, they provide the basic building blocks for controlling network access while you implement some of those controls. That's why some of these things are shared. The blocks are shared in color. While in IaaS, where Azure will provide you the actual computing servers, and you are responsible for managing them just like you would for on-premise servers. So for instance, the network, the operating system, application, identity entirely managed by you as a customer, while Microsoft will manage the actual physical infrastructure, the host, the network and data center security, and so on and so forth. So I hope that makes sense. Shared responsibility model is a very important concept, and you won't believe how frequently people will say, oh, it's in the cloud, so I don't have to worry about patching my servers. That's not true at all. If you own a bunch of servers, you better make sure that those are patched automatically, and cloud provides a lot of options and tool sets to patch your servers on a regular basis. Patch your software, make sure it has proper security scanning software that checks for viruses, make sure your operating systems are upgraded, make sure your for instance, like you have RHEL or Ubuntu, make sure those are all upgraded. So that if you're owning a bunch of servers, like which is true for almost all companies, they own actual servers on the cloud, that responsibility falls on you or your company to maintain them. Next, let's look at some of the key jargons and terms that you would hear in the cloud computing world. What is cloud native? Basically, you're building applications using services that are provided just by Azure. A good example is monitoring, right? If you want to monitor your application, there are a lot of third-party tools out there like Prometheus and Grafana, but Azure provides some native tools like Azure Monitor that are has much better support because it's provided by Azure. Next, let's look at platform as a service, which I think I briefly went into. These are things like app service or managed Kubernetes cluster. Those are all platforms where the underlying infrastructure is managed by Azure, and you as a customer are responsible for managing the application. Next is infrastructure as a service, which is, think about it as actual servers that you rent and you maintain the actual hardware, the actual servers. Next, software as a service. This is less applicable for Azure, but a lot of software is entirely managed, and all you have to manage as a company is access and who gets to access to the applications. Next, let's look at public cloud, which is, Azure is AWS and GCP are public clouds. Private clouds are the ones where a provider will install software within your on-prem, which kind of mimics the way cloud behaves in terms of scalability and reliability. And it's entirely hosted within your company's data center. And behind the scenes, the software abstraction will try to add some of the scalability. But again, private cloud will never come close to public cloud in some of those things like reliability and security and elasticity and things like that. It kind of aims to mimic it, but the main use case for private cloud is for companies who, because of some regulatory compliance or need, they cannot move to the public cloud. Let's look at hybrid cloud, which in my opinion is one of the most common models out there. Very few companies are purely in cloud, and most companies are nowadays never purely on-prem. So there is always a mixed of, okay, you have some of your legacy applications, mainframes, which stay on-prem, but then some of your modern applications are migrated, or even you're natively developed newly in the cloud. So that's what is hybrid. And how do you connect these two things? That's what is the challenge. How do you make sure your applications on-prem can talk to cloud and vice versa? And that's the challenge of having a hybrid cloud, but very common in the the world today. Let's look at serverless. So the term serverless is kind of a misnomer. Really, behind the scenes, there are servers for everything. There are actual physical VMs or physical servers running behind the scenes, but you as a customer do not deal with the servers or maintenance of any of them directly. So essentially, another word for serverless is function as a service. So basically, you just deploy your application, most of them containerized, and the cloud provider will make sure of deploying it, scaling it, and all of those things. A good example in Azure, there is Azure Functions, which is you just write your code in software like Java or .NET or Python or Node, and you just run it. I don't care how it runs. I just tell I need so much memory, I need so much computing power, and the cloud provider will take care of it. Finally, containerization. Think of it as a more lightweight form of a virtual machine. So it has its own kind of operating system, or it's actually operating system is, you get a slice of the underlying VM's operating system, but it's isolated from another container. Basically, it's a lightweight form of a virtual machine, and it's pretty much that is the future. Containerization is what has led to growth of things like Kubernetes and Redshift and OpenShift and those kind of things. So anyway, hope that makes sense. See you in the next lecture.